In a world where
Man of Stone, whenever you are ready, good sir.
Well, all right. You sure you're rolling there?
Yep.
Yes, you are. Okay, looking good. All right, guys. Everybody, thanks for coming. Look at that nice big crowd there. Leftovers. I'll just take Shane's spoils and run. Yeah, tonight is going to be a pretty quick deal. It's a two-parter in video form. My typical style of presenting. Not a lot to talk about. It's just straight up data. I guess to recap a little bit for those who haven't been playing along the whole time, we'll just start up the old screen share here. So everybody can have a peek at that. Hopefully you can see my screen still. It started with Airy tonight. More specifically, the video I put out a couple weeks ago. Taking a look at McKeegan's solar filtered shots of the sun and doing a little bit of composite analysis. I took in the frame we're looking at right here on my screen is a tally, if you will, of how far those sunspots have moved in about 20 hours. And the two things I would point out here about the video are that the angles themselves even are really kind of strange. That these two here in the 930 position are producing, relative to each other, a fairly slight angle. That they're almost parallel to each other, but not quite, in how they're moving across the moon, or sun rather, even though they are apparently at the same quote-unquote latitude of its quote rotation, and others that are near the edge here are entirely a different angle. Notice that these two, actually we should say it the other way around, that these two at this latitude are very slight, yet those two at almost the same latitude have quite a difference in their movement. And all the globies are asserting that this is all happening in a gaseous body where the rate of movement across it in terms of its quote orbital rate of change here would be faster near the pole, or actually wait, no, I'm sorry, it would be slower near the poles, that it takes 35 days to get all the way across here, but only 25 days to get all the way across something closer to this, what they would call equator or solar ecliptic in terms of its own rotation. I was relating this to an original slide or frame that I found online, and I think it's right about here somewhere. There it is. There we go. This is a composite of 25 frames put out by NASA that an astrophotographer in Turkey put together, each of those exposures on the same shot, the backdrop of the sun, so to speak. And what we're seeing here unilaterally are straight lines of progression, regardless of where on the sun you are, which I found to be quite different from what we were looking at here, where, even on the same quote-unquote latitude, here they're not moving straight, here they're not moving straight, here they're not moving straight. They're just not doing that. And that was the basis for what it took to put this video together about McKeegan's slides. Well, actually, this is all second in the video. We'll deal with in the second half of the video, second 2/3 of the video, we will be dealing with the response video put together by Melodome, where he inclusively shows us a great number of the shots that he's taken of the sun from his position in Florida, I guess all at the same time of solar day as the sun goes by every day for 6 months, 7 months even, by the end of what he's doing now, where we're talking in January, where he's, I don't know, he's kind of tearing me apart, and he threw the gauntlet down, so to speak, in a number of ways, and I cover one or two of them in the video itself. Backing up again to Airy, it comes down to this particular frame here and what's been said since I put this video out. And I would point out in the video you're about to watch what this graph actually represents as opposed to what I thought it represents right here in the video from 10 days ago or 2 weeks ago. So that's the background behind what you're about to see for about 5 minutes and change. So let's go to that. And I'm going to mute my mic. And if there's any audio problems, by all means, just let me know, and we'll wait until Elon's balloon link can get back over my head or something, or whatever magic has to happen to keep audio intact. All right, so there it is right about there. Enjoy.
Sleepless hours and dreamless nights and faraways. Wishing you were Heaven knows and Lord it shows when I'm awake. Wishing you were show in a different town on another day. Wishing you were even though you're far away, you're on my mind. Wishing you were
Sunspots near the edges of the sun's disk look distorted.
wishing you were Pay the price, make a sacrifice, and still I'll try.
Our planet is moving away from our sun at 6 inches a year. You guys know that. 15 centimeters a year, our planet is pushing away from the sun. So in less than 500 million years, our planet will be out of the Goldilocks zone. So if we're going to be able to sustain ourselves as a species, we have to become interstellar.
And that's what's up. How'd that strike you guys?
The lensing.
Like
oops,
it, like it.
oops. The lensing.
Got to
Yeah,
mute you immediately. Okay, we're good.
Yep. Yeah, the lensing thing was interesting. Causing the distortion. That's actually, our argument for everything. So.
Just about, eh?
Yeah, that's.
My argument for the distortion at the edge is that we're seeing a disc, and you do get the edge because of the moon. If they off of
What is
a
it?
Cutting in and out, Joe.
Yeah, you're breaking up pretty bad there, Joe.
Yeah, you're cutting in and out. The other thing, so you were showing
I was hoping it was just me.
Yeah. It might be Discord.
What's that?
Thing on Discord. Discord's messing up, it looks like.
everybody's echo.
Yeah, we got to
Can
stop
you stream
watching
anymore,
Stone stream.
Stone?
Yeah, I was about to play it again and put some clarifying comments there so you can have a closer look at some of the frames. But Alan was about to say something. Just want to check for.
Could you just share it without your audio so it doesn't echo? I think that's what's lagging everybody.
Oh, like without the tune kind of thing? I could reshare without the audio?
Yeah.
Yeah, okay. Give me a sec. We'll line that up. And what's up, Alan?
Yeah, so the part where you were showing what NASA would predict or whatever versus what's observed, that was pretty crazy.
Well, that's my question though, because I mean it's taken from NASA from a Turkish astrophotographer, but like what latitude?
Like sometimes when they do like a media package thing, they'll like dress something up to make it look all pretty. So like maybe they made it look that way or whatever, because that's like completely antithetical to their thing, right? To their model.
Yeah, I would say I don't know that it is or not to the model, but they have to make certain assertions about where the Earth sits relative to the sun's own rotational ecliptic, not the solar ecliptic, orbital ecliptic that we are supposedly flying around on with most of the rest of the planets. This has to do with just the sun's reference frame and its own axis, so to speak. And that is supposedly, looking at what the Turkish guy did here in this frame, it's telling us that we're on the same, like that those two ecliptic planes are the same, that the sun's rotational equator is parallel to the planetary ecliptic around the sun. That is how you produce this image here. Or at least it's like this at certain times of the year, say maybe just December or just late June or something like that. You know what I mean?
Yeah.
We could be 6 months out of sync. But if that's the case, again, I would point out now, points to Melodome for submitting 6 months of data. And I'm about to get to that in the video we just watched, where it's really clear to me what's missing from his data based on what we're seeing in both this composite and McKeegan's data. When you put that together and superimpose motion and compare that with the data that Melodome collected, that it just doesn't match up to the heliosexual model like it should. And that's the. I don't think they have one, because I don't think anybody has caught them with their pants this far down. To put it succinctly, that here, let me start it up again for you guys. Well, and I can leave my audio on now, which is good.
Hang on, before you start it again, what was the Aries thing? I missed it at the beginning. I actually looked away for like a split second, and then it moved on. What happened there?
Well, with Airy, it's about this graph and what it represents and what we thought it represents. That we were talking about these two mean values that he posted in the third column, 34.4 minutes, 33.6 minutes of arc. It's on top of the 51 degrees, whatever number of minutes. These are the arc seconds of the value that he claimed to be taking as measurements in terms of the amount of aberration he was seeing through his eyepiece. And it was Hap Rowe, I believe, who on X stated that no, actually, when it comes back to the figures themselves on the 5-pager that Airy put out, there they. Oh, I guess those are some of it. Maybe I didn't post them. I guess I did earlier. It's earlier.
I can pull up a screenshot real quick and send it to you.
I should have it right here. Just before Malcolm, we talk about it. Wow, I was pretty sure I put it in there. But you guys know that the classic 4-column thing that is of the paper, and that
if you check
near
main
column
chat,
3.
there's a picture of it if you want to bring it up.
Okay, yeah, let me bring that up, sure. Right about there. Yes, indeed. So there it is. We see that in down column 3, which is the difference for geographical latitude of the instrument, as in the place on Earth where the instrument is in terms of its latitude, corrected by 4 across from his readings taken in column 1. What we're seeing is that these are the mean difference in the variation of the correction. That it's not actually the aberration involved in these two values or the difference of these two values.
Well,
That's actually just the difference. Pardon?
Oh, sorry, go ahead. I was gonna say Pietro brought a good point about where these, like he didn't move the instrument 100 feet apart, right? He had it in the same spot in the observatory, right?
Well, yeah, it's bolted to the floor.
Right. So that's not him moving the instrument.
Well, it is. It's him taking the instrument at 2 different times of the year, right? And each measurement, right, which are over here, right, absolutely the same spot in the building and looking vertically every time he takes a measurement. But you see each one of these particular values in column 1 are actually the product of 2 readings out of the scope, which is why I showed the difference between figure 1 and figure 3.
Oh, how he could move it 180 degrees to itself.
Yeah, exactly. See, this physical stop right here is where this wing and the wing that goes out the other side that you can't see physically stop right here as you rotate it. This is in its 90-degree orientation where no readings were taken. This thing was swung around counterclockwise, top view, and this would stop its rotation so that you'd be sitting on the right side of the machine as we're facing it and looking in the eyepiece down the bottom. Gas lights above, lighting the reticle, etc. All right, so then he would then spin this thing around to the 180 degrees where the fin opposite this one would come and hit the vertical here and stop it at precisely 180 degrees from the other side of the machine, and reading number 2 would be taken. It was all set up like that so he could do it really fast. So in the viewfinder, if we see it as a circle, not looking at anything we're looking at right here on the screen, but just how I'm swinging my mouse around, if that is the eyepiece we're looking in, Eltonin would be going by from right to left on one of the readings, and then left to right on the other reading as you swing it around 180 degrees. And the wires, of course, would also be parallel to this motion. The wires through which you are looking at the light coming down the telescope and then eventually reflected to your eyepiece. So it's the deflection upward or the aberration upward or downward from it going by this way 6 months at a time that he's actually measuring in this column 1. That 85 arc seconds of aberration or you know what I mean, and 120 around the other way. This is what he was correcting for, to say, oh wait, maybe we are actually on this point on Earth in terms of latitude when we're taking our measurements. And there is a little bit of instrumental error here, which you can see in the graph that I plotted. That part did translate well when we finally got to this. That this spurious reading down here and this one over here, again, we're looking at arc seconds of difference or variance or correction in case of the orders of magnitude of what we're looking at on the graph. So again, all happening within a 900th of a degree or that kind of thing, just for these couple of arc seconds here. But that's really what was going on when we're looking at all of the numbers that are here. That the third column really is a corrected assessment of the variance, not the actual readings themselves. That these are the actual aberrations away from center that he recorded. 19 seconds, 19 arc seconds, not pointing.
So basically,
this is the retraction I'm making.
Gotcha. So basically, he recorded no change from the expected.
Oh no, he did.
From the value.
He recorded 1920 arc seconds up as it went one way, and then 6 months later, 1920 seconds down as it went the other way. That's why these are negative values and these are positive values, away from the zero line going through the eyepiece. As things go left to right or right to left in the reading.
The difference for geographical latitude of the instrument, right? Isn't that just the second column minus the first column?
Isn't it more like the second column minus the fourth column?
No, I think the values are precisely column 2 minus
yeah,
column 1
34 and 18, 59.
29,
Really?
59,
Okay.
and 28,
Well,
34. Because otherwise,
it would be 34 plus 59 eating 85, right? Seconds, arc seconds, arc seconds, arc seconds.
the extra
34,
minute is a
59.
60.
That would be like 94, and this is, which
No,
is an extra minute.
It's 85.3 because the minute's 60, and then the additional 25.3 from 34 to 59.3. It's precisely the first column.
You're still not telling me what you're seeing.
I'm saying if you take the number in the
Try me again?
second column and you subtract the number in
Yeah.
the first column, you will get precisely the number in the third column. So column 2 minus column 1 equals column 3. It's
Okay.
precise.
Okay.
So the column 3 is not supposed to be a literal physical location because his observatory didn't change location, right? If 1 arc second is equivalent to 100 and something feet on the ground, he's got changes of 2 arc seconds every day. The observatory is not moving 200 feet.
Right. So that column 4 is column 2 minus column 3 as well.
No, it's column. That would be
So
column
these
1.
are the differences. Say what?
I think column 4 is what the nautical almanac reports, as per the correction, or it could just be what he measured as per the nautical almanac. One of those two. But if you notice it goes up from February 28th to March 21st. It rises in value up until the equinox date, and then it goes back down. So it's increasing, and then it hits the high point, and then it decreases. So that, the way I read it is that it says it's adopted in the nautical almanac. In other words, he looked at the nautical almanac, and this is the number they said you should be getting for aberration.
As in, this should be the number you're getting for aberration.
The fourth column.
Okay. Well, let's say it's even these. Let's say that this was the aberration that he was getting in his lens, which I don't think he was, because this is talking about the correction, right? Not the reading. This is observed over here.
Yeah, that's how far it is from zenith. So
That's the whole point.
A perfectly zenith star, because the star wasn't perfectly zenith. A perfectly zenith star would be 20.
Right, at 90 degrees,
seconds.
right? So this,
Right.
exactly.
So that extra little bit away from zenith is why it wasn't 20.5 degrees. It was ever so slightly less than that because it wasn't perfectly at zenith.
So what we're saying is that what I presented in my graph were these data points as if those were the aberrational values, and they aren't. This is why I published the retraction.
The first column doesn't follow the same trend line as the fourth column, and so that's why the averaging is necessary. I think his point of the mean latitude deviation between the spring and the fall was to denote that there wasn't any significant change, that the measurements could be trusted as actual.
Except that they're on the other side of the line because you're at the other side of the year, allegedly, the other equinox. So
Right,
they are
that's
definitely
how
changed.
they
They're on
treat
the
it.
other side of the eyepiece, right? Yeah.
Right.
So
the Earth
anyways,
would-
this was
yeah.
the basis for my retraction. That's what I'm trying to say.
So, I missed. So
You cool on that?
specifically, yeah. So specifically, what are you taking back? I mean, in light of this.
That these are not the readings. That these are a corrected difference. They're not the readings themselves. They're the variations in the readings. That's all I'm saying. Anyways, it was a case of mistaken identity in the data. That's the only reason I published the retraction. And I also put into the video, which we can watch again right now if you like, that, again, I wanted to stress that nothing about this proves nor disproves, validates nor invalidates anything about cause. And I think that's the bigger issue in the first place. Is that we've got to be addressing with the globies, we have to be, find more coherent ways to talk about the cause of what would be the cause for aberration of light, whether we're measuring it here or not. You know what I mean? That there are, and even the bigger issue at the end of the Aries video, which still stands, about how 153 years later, spinning the Earth 85,000 times later, that star is still in exactly the same zenith spot at exactly the same time of year, at exactly the same time of day. And the globies have a lot of explaining to do when it comes to that. They can't just say, oh, that star's really far away. Oh, the solar ecliptic never changes. Oh, no, Earth's orbit, Earth's axial tilt, rather, never changes. Not even the slightest over 153 years. When we talk about the physics of gyroscopic precession and what have you, it never seems to come into play when we actually observe. And I think that's where we need to take the globies to task. Is that agreeable?
Yeah. So we're still in agreement that he didn't get from the air medium to the water medium. He didn't get any additional aberration.
At this point, I'm going to have to break it down from zero and look at it all again. I'm not really sure what this does or does not say at this point. I'm just trying to be fair to the audience. And I don't want to give people things to say that aren't necessarily true. And if I'm not confident behind something, I'm not as apt to say it. You know what I mean? I'm just trying to stay real. All right, so let's buzz on back and take it from the top. You guys ready?
Yep.
Good stuff. Well, I get to hear the pretty song. You don't. But this will be going up on BitChute.
Yep, it's on.
Of course. Very soon. Oh, you can hear it? It's pretty quiet. Here, let me turn it up. I don't think you guys can hear that.
Nope.
No, we can't hear it
Can you hear
anymore.
the guitar? I don't think
Nope.
so. No,
Nope.
let's leave it down then. Yeah, it's pretty awesome. We'll talk about the trivia afterwards. About that particular track. There's some trivial question I'm going to ask you guys after. So that's just saying the first part of the video is still all correct, and the last part of the video is still empirically correct, because that's what's in the sky. All right. And this really is what it came down to. In Telegram, I received a number of posts from Globies, sea lions, and the like, and I'm only submitting 2 of the examples here as absolutely representative of the content of what the Globies tried to send my way in explaining what I was pointing out. And there's the first one. And I mean, really, that took a lot of effort, didn't it, guys? Look at that. That tells me everything I need to know. Right there. And same deal. Okay, this is the bigger point, and where I wanted to start you mentally, putting your picture together of the universe model, and how, if we're swinging around it, just like in my couple of thoughts about the sun video, where she goes around in circles, we're supposed to be back in the same point in the celestial sky every December. And it's to the nth degree of precision year to year that it's exactly the same place. We see the same stars in the same position relative to the sun's motion at the same times of day, always in December every year as it goes by. 153 years in a row from when Airy was paying attention. And this is the bigger point that you need to keep in your mind when you see the rest of what I present here. And that's right out of my video with the word December plocked on the top. That here we are at December, where you can see South America has got their summer going on. And down in Antarctica, that's supposed to be when the sun was visible all the time. And the Globee model, this is exactly what they're pointing at. However, when we integrate that with what we're seeing in terms of McKeegan shots and melodomes, and I do like those titles, guys. My sash has not arrived in the mail yet, but I'm waiting. I have faith. I have faith. It'll be here someday. But this one I thought was funny, so I'll give him points to Brian Cash for making a very adroit point. Thanks, Brian. For sure. And this, I will not stop. You guys can, again, review the video on your own time and read our little conversation. There's not a lot to it. There's not a lot to it, but it took place. And I think Austin may have forgotten about that when I was the guy helping him out. Anyways, so.
Yeah, you definitely shouldn't have. Those were DMs with him, bro?
No, those were right out of the Miswits channel.
Oh, okay.
Where I was publicly helping him do it.
Oh,
Oh, no,
okay.
there's nothing private here at all.
Okay.
No, certainly not. I'm glad you asked, Alan. Don't ever hold on to that kind of doubt. Get it out and figure it out and get the truth. That, no, those are still something you can go to the Miswits general tab and search for them and find them. It's still there, public record. Absolutely. So this is a piece that I pulled from his video. And here they are, without any of my plot tracking them. I actually split these up into 6 different 23, 24, 25 frame sequences, and then did exactly the same to all of these shots that I did in my Sunspots video with McKeegan's work. That I put lines to them and tried to find an average for the direction that they're going, and they're all pretty similar. You can see that they're all going up to the right like that. Keep that in mind when we get to the next bit here too. Now we're seeing a rotational axis quote where the north, so to speak, would be off at about 10:30 and the south down below at 4:30. You know? Okay, so I'm translating that onto the Earth here, but it's actually demonstrative because it's got the lines all over it. So take a look at June up there, where it's a little more rotated than what you just saw, where the north axial is over at 9:30, maybe 10 o'clock in June. But if that's the case, and we're swinging around in orbit at 30 kilometers per second, 30 days later, that north orbit's going to be way behind, and we're going to be seeing more of the south. And then August, we're going to see more of the south. And then September, the south is going to be pointing directly at us, etc. As we swing around in orbit. This is how things should be changing in how we see sunspot movement across the sun. They should be moving similarly month to month how we see these continents moving across Earth here. In fact, this is kind of the way we see Earth from the sun. And that's only the first 6 months. The following 6 months, you would see Antarctica completely disappear, just like we saw the North Pole disappear from June forward. That we would see the other 30, 60, 91, 21, 50 degrees rotating the other way. And we don't see any of that in Domi's data. And this is it, where we see the axial doesn't really change much like it should 30 degrees month to month. Here we are in June at the top of the stack, right there, and we're going to go all the way through the end of November just about. You know what I mean? That's all the same way. It's not changing orientation. And that's what this is about. So then there's, of course, Domi's misinterpretation of what he thinks he's looking at. And here we are looking at the two lenses. On the left, the spherical lens. And, you know, I'm not saying that's what the sun looks like for sure. I'm saying it's looking a lot more like the one on the right, with a little bit of what's on the left around the edges. Which is why when I was showing you the frame from my sunspots video, where I extrapolated their motion, and you can see the angles at which they're moving are quite different across its face. This very well could be why. That there's a little bit of spherical distortion in an aspheric view of what we're looking at being the sun. And while we're talking about the edge, this is what is important. And this is a Crow 777 frame, one of his filter types, and a fairly common one because I've seen this color from other people also putting out their material. But you can see that the intensity, especially at places like 5:30, 6:30, 8 o'clock, 10, 10:30, it's brighter right out to the edge. I mean, we're looking at a fairly compressed image of the color itself, so it's not handling the gradient very well. It's pretty rough, but at least that's, you know, representative of what's going on here. And here's your zoom in with the same point, that it's bright all the way out, just like the moon. You guys notice that? That when we look at the moon, we don't get any spherical attenuation of the brightness as we move to the edge. Hopefully, I'm not the only one who finds that conspicuous about what we're looking at in terms of celestial objects.
That's a,
So I tried to be fair. I tried to be fair and keep both sun images in this stack. What were you saying there?
So I personally think that the moon and sun are concave at their disk. And that's the distortion that we see with the craters at the edges of the moon, and that's the distortion we see with the sunspots at the edge. Because that distortion that he's calling spherical distortion would occur on a concave surface. And if these lights are projected onto or off of a concave dome, then they're going to be concave at their disk, or at least appear to be. And when I would agree. When I do astrophotography,
I would agree.
Yeah, when I do astrophotography on the moon, I see that all the time, and I'm convinced that the surface is concave. Plus, a concave surface gives you a better view with less distortion, no matter where you're at.
I would agree that it's really hard for us puny humans down here on the surface to confirm whether we're looking at convexity or concavity. that it's just, how are you going to do it? You know? So I tried to be fair and at least keep both images that I pulled here. That there's one sun, just to be fair, a little bit of red on the outside of it. And again, when we look at this lens here, look what's going on in terms of this is really bright, and okay, there may be trees in the way, but you can appreciate that things are getting darker over to the 9 o'clock position, excluding what's being reflected here in the foreground. That ground is fairly bright here, and then just over here, it starts to get a little darker. And this is the influence. And you have to make up your own mind. I guess this is a subjective thing, which is why I'm showing them in rapid succession and how similar they are, that you have to decide what you're looking at. And this is my favorite Terrence Howard moment of everything he's ever said publicly. This is either Oxford or Harvard. I can't remember. And it's over here on the right. I got to look a little closer. One of the two. He's speaking at a learned academy in front of undergrads primarily. And this is what he says about how somehow the sun being 93 million miles away, somehow we are able to determine such an incremental change anno to anno. Our planet is moving away from the sun at 6 inches per year. You know that? 15 centimeters per year. It's getting farther away. So in less than 500 million years, we got a problem, boys. So we better go interstellar.
Their only way out.
It is my favorite moment in time when it comes to this guy. Even better than reading his patents. Yeah, that's... Thank you, Terrence, for such an entertaining evening, presenting your thoughts. So yeah, guys, that's where we're at. Let me here. I'll kill my screen share. I think we got the basics across. And yeah, any other questions or comments from the gang?
No, man. Thanks for the Prezi, and I hope you follow up on the Aries thing and figure that out, because it would be nice to know what was actually measured. But I guess the general consensus from that experiment at the time, though, was that, you know, nothing was measured out of it. So I'm not sure how they extrapolated that out of the data set. But there is a phrase in there that it says Professor Klinkerfuse's hypothesis is untenable. And his hypothesis was that when he introduced turpentine into his telescope, he measured the angle increase. So I'm assuming, even though that data might not be in there or whatever, that was the outcome based on that, him saying that with, you know, phrasing it in that way, falsifying the hypothesis that was stated by Klinkerfuse.
Yeah, I agree on your interpretation of what he's saying there too. I think that is what he's driving at. I really, like you say, I've got to get back to the starting blocks on looking at the data and seeing if that really is backing up what he's saying about it, that it's not tenable and that he didn't measure it. And yeah, new set of eyes, I guess. I want to take a look at it all again, just to see, to be sure. And I think that's what's called for. That's science, right?
Absolutely. And shout out to Hap. I mean, I would have never listened to him or whatever, so I'm glad you did. I'd rather argue accurately.
It's double for me.
Dude, I'd rather argue it accurately than, you know, be wrong about that one little point or whatever, because the sentiment is still the same and the outcome is still the same. So otherwise they would use it as proof of their model. So
entirely.
Yeah, that last column, that's like just a little bit less than 20 arc seconds, because 20.5 or 20.4 is for a zenith star. It's like an arc minute and some change away from zenith, which would explain why it's like a fraction of an arc second below 20. But if that's the aberration in that last column, the fourth column, then it's definitely not 27 or 26 like it should have been, right? It's unchanged. There should have been a difference of at least 6 point something arc seconds compared to the standard correction for aberration.
Sure enough, that is exactly what we've got to get to the bottom of. But I don't know, guys. I think the big showcaser point of everything I've presented tonight has to do with lack of apparent rotation of the sun's rotational axis as we go around it. That in itself is absolute flat smacking ammunition in extremis. That the globies have a lot of splaining to do as to why we don't see that if we are in orbit. Yeah, and it's like, hey, there's the evidence, there's the data. Feel free to tell us it's fake or something. You know, this will be Sunspot Gate or whatever else they come up with this week. But frankly, I think that's the gift from tonight. Good question. I don't know, man, but we always seem to talk about a spinning gas ball with different rates of spin, latitude dependent different rates of spin, that it just spins slower on the higher latitude of its alleged axis of rotation as a gas ball. And if that is all true, then why do we not see an apparent change in orientation of that axis as we spin around it? And I can't wait. I can't wait to hear their explanations to that, you know.
Well, my question would be, if it's latitude dependent on the sunspots, then what latitude was that astrophotographer, the Turkish one? What latitude was that at? That's from NASA?
Yeah, that's from NASA, and that's supposedly on the equator of its rotational. You know what I mean? Because all the sunspots are all going straight across, which is why I drew out the lines of latitude on a disk so that you could see that relation.
What do you mean all the sunspots are going?
In that shot, let me I'll share my screen again just for a sec.
I know the composite, but I'm just saying, is that latitude dependent? Because where Melodome took his observations from, right, which was like what, Colorado or something like that?
Florida?
He's in Florida.
Florida. Wouldn't that be a different orientation to the sun, which would give it that kind of like spinning,
maybe
look?
But that's the thing though, is it's one orientation, and that we don't see any month-to-month change in that orientation, right? What I'm sharing my screen with right now would have us believe that Earth's orbit, at least in this month of December, for these 25 days that all of these were taken, where there would be 28 or 27.6 degrees of rotation in the orientation at which we see this, they would have us believe that we're skimming along parallel and on the same plane as the sun's rotational equator. That the planetary ecliptic is parallel and the same as that. That as we spin around it, taking these pictures for 25 days, watching these sunspots go across, straight line, straight line, straight line, pretty much a straight line all the way across. Nothing compared to, or not even remotely close to what I'm showing here.
I don't know.
You know, those are not moving straight. None of them are. You know what I mean? Well, maybe one of them is if the rotational axis is we can see more of the south of it than we can the north of it currently, which is why in the video I show that with the spheres. This here. I show this motion, and that we should be observing a change in the orientation of the motion month to month to the tune of 30 degrees. If we're doing 360 degrees in a year, every year, exactly the same 360 degrees, right? That we don't see this change when we're looking at the 6 months of stuff that Domi here is showing us, where it's all the same, essentially, give or take 10 degrees maybe. It's all across the same axis. You guys seeing that?
Yep. Yes.
Cool. I mean, that is the big bat with which we will club the globies over the head and say, all right, explain that.
I'd like to get a good steelman from them first before we even present it.
Well, I think we can draw one. We just open up the astrophysics textbook where it shows the ecliptic plane and it shows sunspots moving in one way, and we've got the data right here. They just don't match up.
Yeah, I'm just saying, like, I would like to hear like a blitz or somebody that, you know, can be like, nope, this is our position on sunspots and the sun's axial tilt, etc., and then present. That's just how it should.
Sure. Get them in a big gotcha. It's just snap them like a twig, boys. Go
Like,
to it.
we would never see that part of the sun because of the Lorentz contracting ether drift from afar, which would then, of course, become sulfide, and then we'll mathematically invert the coordinate system from the bipolar radii. We'll apply Lorentz scaling factor back from the center, and we won't even notice from the frame of the light itself, Fleur. How's that?
I think we better tap Franco for some Scupo equations to cover this.
Might be out still.
Right on, boys. Well, that's what I got. That's how we're rolling tonight.
Good prezzies.
What a night. This is a good night.
Double feature. Thank you,
Run
Stone.
Ball is about to be on Strange World. He's probably on there right now.
Oh,
Oh, dude,
nice.
triple header. I forgot.
Nice.
Who's on? I missed that.
Tune in to Strange
Going on, Mark
World.
Sargent.
Oh, yeah. He said he'd be on a little bit later, so we'll be able to catch that. That'd be cool. Nice watch party. Yeah.
Yeah, he should be on there right now. He said he was going on at 10:30.
Nice. All right. Well, let's wrap up the second stream then, unless anyone's got more questions.
Nope, I'm going to go ahead and wrap it.
Right on, guys.
Thank you,
Yeah,
Stone.
thanks for coming.